slide over you two. So we're ready to go. All right, when we talk about scientific notation, we're talking about writing a really big number in an easy to handle manner, okay? So, this is a big number. It's kind of hard to decide what you would say if you would read it, unless you put the commas in, right? We do them every three, starting from where the decimal is. There, now we're in thousands, millions, billions. What would this be? Trillion. Okay, so you got the idea, you can name them. Now, when we write a big number, we write it in pieces. We first will have a number, a decimal, and then whatever else we may need. Times 10 to a power. All right? When we move the decimal, we're going to always move it so that it is between the digits. This number right here in front has to be between, it has to be greater than 0, but less than or equal to 9. You can have it 9, but you can't have it 10. So there can only be one digit here, and then whatever decimal pieces you have left. Then the power, well, how many places did you move it? If I move left, that's bigger, and I'll have a positive number. So I count here, well, 3, 6, 9, 12 to here, but I need one more, so the power would be 13. So my official answer is 3.2 times 10 to the 13th. All right, now, I have notes that I'll have you copy on another page. Now, how about a really small number? Now, these basically work the same way, and I'm going to use commas just to help keep things organized. But again, I went from the decimal, and I went here, okay? Where do I want the decimal to end up? Between the 8 and the 0, so that's where my new decimal is going to appear. 8.07 times 10. Since it is a small number, the power is negative. 3, 6, 9, 10. Yeah, you've all done this before, correct? They're going to ask you some questions. Is it written in scientific notation? Yes or no? And basically you have to look right here at this first piece. There can only be one digit here. If there's more than one digit, then it's not written in scientific notation. All right, so let's go to the official notes, which are right here. Scientific notation, here is 35 million. We write 3.5 times 10 to the 7th. This number has to be greater than 1, but less than 10. It can be 1, it could be like 1.2 or whatever. The power, if it's positive, means we have a big number. If it's negative, we have small numbers. Okay? This is the only notes that you're going to actually write down, but I don't want you to write down right now. I want you to watch. What kind of power am I going to have this on this one? Positive or negative?
Negative.
So what's going to be basically the first piece, the numeric part? 4.71 times 10
To the negative
3, 6, negative 8 power. Okay? Here, what will be the numeric part?
1.479.
Times 10 to the, okay, there's the comma, so it would be the 5th power. Is this one written in scientific notation?
No,
No.
that'd be
8 times 10 to the,
0.
well. That's supposed to be 1, isn't it?
yeah,
So it would be 8 times
8 times 1 would be 8.
Oh,
If you don't move the decimal, then it's times 10 to the 0. Because 10 to the 0 is 1. 8 times 1 is just 8. Now, the only special ones they're going to give us are like this second one. So you're going to be given this. You're going to take the 8 times 7.1. Well, that's 56.8. I made it an easy one that you can do in your head. Times 10 to the 8th. Is this in scientific notation?
No.
No.
It'd be 5.6.
So what's gonna happen, the decimal needs to go one more position, correct?
Yeah.
So do you add or subtract on that power?
Add.
Add because you're going left. All right, take a moment to copy this down. We need to look at whether they give you one in scientific notation and how to write it in standard form. Are we ready? I was taping yesterday and somebody did an alert on the phone for an all call. So, yeah, it's part of the video. All right. Give me an example that's in scientific notation.
3.1.
Michael, what power? Okay, who can write this in standard form? You've already been out, Kurt. But thank you. Is it a big number or a little number?
It's a little number.
Okay, so we start with 0 point. And I do expect 0 point when you do small numbers.
Alright, so,
How many zeros are you going to have?
7, 8, 6.
When you have small numbers, you always will have one less than the power. Now, the only thing wrong with it, I need to see that decimal a little bit.
I'm sorry.
Okay. But again, when you have a small number like this guy right here, you always have one less power. All right, now let's have another one that's a big number. Now we've already
7.59.
7.59 times 10 to the,
32nd.
how about 13?
Okay.
Okay, Miranda, as long as the videos keep going, or did you shut it off already?
Well, it's on.
Well,
So go-
set it up.
It's
Well, I don't know.
the case sentence. You don't even have to
So
tell.
we're going to have some black spots during the video. How many zeros on this one?
12. 11. No,
14.
no. 11.
I should have.
Then make sure you do put commas back in. Now, when we have this power of 13, if you have 2 extra places, you basically subtract those 2 from there, and that tells you how many zeros to be dealing with. All right, at the moment, all we've done is scientific notation. Basically, they give you a number in standard form, you write it in scientific notation, or they give it to you in standard, or in scientific notation, you go to standard. What if they ask you to compare numbers? On your homework, if you look at number 24, and this is on your homework, number 24, if you get this problem, and you can put your notes away. they say order the numbers in each list from least to greatest. Now, when you order these, you really need to see what they are in standard form. So if I would write this first one, how many zeros would I have? And the next one has how many zeros? And our third one has how many zeros? And our last one. All right, since the instructions say least to greatest, which one of these numbers is our smallest?
6 to 10.
When you write your answer, you will write 6 times 10 to the negative 10. You are not going to give me this form. If they give those to you in scientific notation, I want it back in scientific notation.
But when we do that, do we actually have to write out those numbers?
This is just to make sure you understand the process. You got to be careful if the powers are the same. Got to be careful. So what would be our next one?
8 times 10 to the negative 8.
Our third one? And our last one is 7 times 10 to the negative 6.
Does that work on all of them? Like, you can just go by the lowest.
If the powers are the same, you're going to have to look into it.
Or if not.
Pretty much. Okay. Least to greatest.
So we don't have to write all of them.
I'm not expecting, I just wanted to make sure you understood what it meant, least to greatest. All right, do you have questions? Turn it off. All right, if you turn with me